Alright, that last video was a bit of a marathon. 4 proofs of 4 different chord theorems. Wow. These are a little bit nicer. Angle properties of circles. Theorem 1. Angles at the centre and circumference. What does it mean? The angle at the centre of a circle is twice the angle at a point on the circle, provided they are subtended by the same arc. Well, we want to actually prove that this is always true, not just take my word for it. Why would you trust me? Oh, look, it's a yellow circle. That's beautiful. I'm going to change my pen now before I forget. We'll go with that though. There's my center of the circle, and here's any point on the arc, on the circumference. Now I'm going to choose this arc here. Doesn't really matter. And what I'm trying to show is that angle on the edge, the circumference of the circle, is half the angle at the center, or that the angle at the center is double the other one. And we're going to use a little bit of mathematical magic here to get that done. I'm going to, first of all, why is that not blue? I chose blue. Let's try again. I'm going to first of all draw that in blue. Now here's the trick. If I extend that line through, I'm going to call this angle here 2x. Okay, we'll see why in a second. It works fine if you call it x, it's just a lot easier to look at if you call it 2x. What I know is that 2x plus that angle theta must equal 180 degrees. That's fair enough. Now because this line and this line is a radius, I know these bottom angles, I'm going to call them alpha and alpha, they must be equal. So I know that 2 alpha plus theta is also equal to 180 degrees because they're the angles inside the triangle. Well, it doesn't take a genius to figure out from that 2x must be the same as 2 alpha, or alpha is equal to x. So I've shown that this part, that angle there, is x. Now that hasn't really proved it for the whole angle yet. I said I was going to have to show that the entire angle at the center was double the angle at the edge. Well, I've only shown part of the angle at the circumference and only part of the angle in the middle, but I'm going to use the same rule to prove the rest of it very easily. I'm going to call this angle in there 2y. Again, the radii make the edge angles equal. Now I'm running out of room there, so I'm going to call that beta and that beta. We just traditionally use Greek letters to represent angles. You can see by the same principle though, 2y plus, let's call that alpha, beta, let's go for gamma. 2y plus gamma form a straight line, so that's 180 degrees. And I also know that 2 beta plus gamma equals 180 degrees because they form a triangle. What does that imply? 2y equals 2 beta, y equals beta. So that's the same as y. So this angle at the top then is x plus y. Well, this angle at the bottom was, if I take that entire angle, 2x plus 2y, or 2 times x plus y. 2 times x plus y, which is obviously double the angle on the circumference. So it doesn't matter where you are on the circumference, that will always be true. The angle subtended at the center of a circle is double the angle subtended on the circumference by the same arc. There you go. So our second theorem here, the angle in a semicircle is 90 degrees. Well, that's really just a special case of our first theorem. Let's have a look. Oh, didn't give me the right pen. Come back here. So here's our arc. You can see it in green there. The second time I got it to work. Here's the angle subtended at the edge of the circle. And here's my angle subtended at the center. And you'll see, obviously, if this is a diameter, it's a straight line. That must be 180 degrees. And then if I pushed those two radii out and made those lines extend, so move that point out to the edge of the circle, it's going to be half the size, or 90 degrees. So it's really just a special case of the other one. But it's nice and easy, because then if you have any semicircle, you will know straight away that wherever you draw points from the diameter, doesn't matter where, the angle will always be 90 degrees. Nice and easy today. Alright, good luck with the questions. Cheers.